Welcome to video number 9. We can crawl the system. Now, we need to multiply. Today, we master the replicator. We are learning the most powerful system call in Linux, fork. So think about it. You've got that shell, you've got access, but you are hanging on by a thread. Just one kill command from an admin who's paying attention, maybe a tiny network glitch, or even just closing the wrong window, and puff, you're gone. All that hard work, completely wasted. This is the fundamental problem every attacker faces: persistence. To really solve this, we first have to understand why we're so vulnerable. Right now, we're basically operating as this single lonely target on the system, and we need to define exactly what that is. Now, there's a really important distinction to make here. A program, that's just a file sitting on a disk. It's totally passive. But a process is that program in motion. It's alive. It's an active entity inside the OS. That's the thing that's actually running our code, our malware, our shell. And right there, that's our biggest weakness. If your whole operation is tied to just one single process, you've got a massive single point of failure. The second a sysadmin runs PS, spots your sketchy process name, it's game over. They kill it, and you are booted out. To survive in this environment, we can't just have one life. We need to be able to multiply. So how do we do it? We're not just going to start another program. That's messy. It's loud. No, we're going to use something far more elegant, way more powerful. A system call that is the literal heart of how Linux creates processes. We are going to master fork. This is a concept you've got to get your head around. See, unlike some other systems where you create a new, empty process and then load a program into it, Linux does something way cooler. The fork system call makes an exact, perfect, functioning duplicate of the process that called it. It's not creation from scratch, it's replication. You make a perfect copy of yourself. And this is it. It looks so simple, right? PID-T fork void. No crazy parameters, no complicated setup, it's just one function call. But it holds this amazing paradox. You call it once, but it returns twice. Once in the original process and again in the brand new clone. This quote really nails it. It gets right to the core of what makes fork so powerful and, let's be honest, a little bit mind-bending. One call, two returns in two totally separate processes. So that begs the question, right? How does a process know which one it is? Am I the original or am I the clone? And this right here is the absolutely brilliant answer. It's all about the return value. In the original process, what we call the parent, fork returns the process ID, the PID, of its new child. But in the clone, the child process, fork returns 0. That single difference is everything. It lets our code ask a simple question with an if statement. Am I the parent or am I the child? So this gives us our tactical playbook for staying alive. Step 1, call fork. Step 2, check that return value. If we're the child, if that value is 0, then we keep on running our payload, our shell, whatever it is, now totally detached in the background. And if we're the parent, well, our job is done. We made the clone, now we can just quietly exit, close our original connection, and vanish. The admin might see the first process die, but they have no idea our clone is still running. Okay, we've seen how to use fork for stealth, for survival, but this tool, it isn't just for defense. When you use it aggressively, it becomes one of the most vicious denial-of-service attacks you can possibly imagine. Just look at this. It really doesn't take much. A simple loop. The first process creates a clone. Okay, now there are 2 of us. On the next pass through the loop, both of them create a clone. Now there are 4, then 8, then 16, 32. You see? The growth isn't straight, it's exponential. And this all happens in microseconds. Seriously? Think about that for a second. What happens when a process that replicates itself exponentially is put inside a loop that never, ever, ever stops? What do you think happens when you point that kind of weapon at a server and just pull the trigger? This, the fork bomb. It is an infinite loop of pure runaway self-replication. Every single process creates a new one, and every single one of those new processes instantly creates another. In less than a second, you have thousands, then millions of processes, all screaming for CPU time and RAM. The system's process table fills up, it runs out of memory, the CPU is slammed to 100%, the machine just freezes, solid. It's a complete, catastrophic denial of service in one single line of code. All right, let's pull back from that absolute chaos. Using fork function for a DOS attack is Well, it's loud and very destructive. For our stealthy operations, we need discipline. We have to clean up after ourselves. See, when a child process finishes its job and exits, it doesn't just disappear into thin air. It needs to report back to its parent, give it a final status update. If the parent isn't listening for that report, the dead child leaves behind a little ghost in the machine, a trace that a good sysadmin will definitely spot. And that ghost is called a zombie process. It's dead, it's not using any CPU, but it's still taking up a slot in the system's process table, kind of like a ghost. A bunch of these zombies building up is a huge red flag that something weird is going on, that some parent process is just creating children and not managing them. It's sloppy, and it's how you get caught. Now, on the flip side, if the parent dies before the child does, that child becomes an orphan. The Linux kernel is actually pretty smart about this. It automatically adopts the orphan, reparenting it to the main init process. This makes sure that when the orphan eventually dies, it has a parent to report to so it doesn't become a zombie. This is the exact mechanism we exploit to get persistence. So, to avoid leaving a trail of these zombie processes, a well-behaved parent uses the wait system call. Wait basically tells the OS, hey, just pause me right here until one of my kids finishes. When a child terminates, wait wakes up, collects its status, cleans up that zombie entry, and lets the parent get back to work. This is the key to clean, stealthy operations.
So what's the bottom line here? We've learned that fork isn't just another function. It's a core concept and has two very, very different sides.
Let's just quickly recap. Fork is your #1 tool for survival, letting you create clones that live on long after you're gone. The secret sauce is that return value. 0 for the child, the PID for the parent. That's how you control everything. But take away that control and it becomes a devastating weapon, the fork bomb. And finally, to stay hidden, you must use wait to clean up your children and leave no trace behind. You now understand the replicator. You have the power to create life on a system, to multiply your own presence, and with the same tool, to bring that entire system to its knees. That's an immense amount of power for both creation and destruction. The only question left is whether you have the discipline to actually control it.